You need to see this. This could change everything you think you know about physics. These incredible pictures aren't from a sci-fi movie. They're real photographs of our universe. They show the amazing power of one of the greatest theories ever, Einstein's theory of general relativity. But hold on. Before we can talk about Einstein, we need to go back to the man who started it all, Sir Isaac Newton. Newton wondered why, when we let go of an apple, it falls down. He thought there was some force acting on the apple, an attractive force between the apple and the earth. And he was right. His theory of universal gravitation explained how every object attracts every other object. But it got complicated when scientists tried to use it to explain what's happening in space. And that's where Einstein came along. Einstein turned everything upside down. He said gravity is not a force. Instead, he said, space is squishy, space is curved. What appears to be a force is actually an object rolling around in space following the curves. So let me get it straight. Einstein says gravity isn't a force. Gravity is geometry. Yep, that's right. Space is a kind of fabric that stretches and bends. Call it space-time. Imagine space-time as a trampoline. If you put a bowling ball on it, the ball will sink into the trampoline, creating a dip. Now take the ball away and place a marble near it. The marble will roll toward the dip. That's exactly what happens in space. Planets and stars warp space-time around them. And other objects move toward those curves. They follow the bends, which we experience as gravity. So forget about forces. According to Einstein, gravity is geometry. Space is curved. Objects roll along those curves. But it gets even crazier because space-time isn't just curved by mass. It's also curved by time. That's right, time warps space. The closer you are to a massive object, the slower time moves. If you were to stand on top of a skyscraper, you would age slower than someone at the bottom. Of course, it's a tiny difference, but measurable nonetheless. Your phone's GPS has to account for it. Satellites orbit high above the curve of Earth, so their clocks run faster. To keep things accurate, GPS satellites have to lose a few minutes every day. Otherwise, they'd be telling you to turn left when you're already 3 blocks ahead. And we're not done yet. Space-time is curved by mass and time, but so is light. That's right. Light bends. When you see an object far away, you don't actually see the object. You see the light that bounced off the object. Light travels in a straight line, but when it passes close by a massive object, its path bends. And once again, Einstein predicted this. In 1919, scientists watched a solar eclipse and measured the bending of light around the sun. They compared what they saw to what Newton predicted. And guess what? Einstein was right. Light bends around massive objects. Space is curved. At first, most scientists rejected Einstein's ideas. They thought Newton was right. But experiments showed that Einstein was right. His theory fit the data. Over time, more and more evidence supported Einstein. Today, it's one of the cornerstones of physics. Why does any of this matter? Because Einstein changed everything. His theory of gravity helps us understand black holes and the Big Bang and everything in between. It also predicts things that haven't happened yet. For example, gravitational waves. These are ripples in space-time caused by accelerating masses. They were predicted by Einstein a century ago, but they weren't detected until 2015. These amazing pictures were taken by the LIGO scientific collaboration. They captured ripples from a pair of merging black holes. Space is not empty. Space is full of wonder. Thanks for watching. Subscribe for more mind morsels.